Okay, for example 4.2. So for this example, we are going to scrap this one because it's too brief. So we change to another question which is a little bit more detailed compared to this one. So example 4.2 is changed into this question over here. So please take note as this example, this slide is not included in your given slide. So you might want to maybe screenshot or do something so that you can record this slide here. Okay, so here example 4.2 is given as the waveform for the voltage across the inductor for a buck converter in continuous conduction mode. Okay, so continuous conduction mode CCM as below. Okay, so continuous conduction mode means that this is our assumption for the buck converter. Okay, so now using this waveform we are going to find the duty cycle D. Okay, so for a voltage across inductor from 0 until t as given over here. Okay, if you write that down, okay, the total voltage across the inductor is also equivalent to the voltage across the inductor during the switch is on plus voltage across the inductor when the switch is off. Okay, so this is also equivalent to the condition where the inductor is being charged and then being discharged, and this is also equivalent to 0. So you charge first and then you discharge, so the total of the voltage across the inductor will be 0 at the end. Okay, so here we also know that the integral of a waveform is also equivalent to the area under the graph. Okay, so when switch is on, this is area under the graph for when switch is on, and here is the area under the graph when the switch is off. So let me give it as area number 1 and then area number 2. Okay, so here this part when the switch is on is equivalent to area 1 plus area 2 is equivalent to 0. Okay, so here we are going to use this relation and find the D, duty cycle. Okay, so here this is area number 1. So Vs minus V naught. So we have the width of this waveform as dt plus, so for this one we have the height is minus V naught, and then we have 1 and then t. So this is equivalent to 0. So here Vs minus V naught is equal to V naught d. Okay, okay, sorry, I have t over here. Okay, so when we rearrange this equation later on, we will come to the conclusion that T, the duty cycle, is equivalent to V naught over Vs. Okay. Okay, so here D, duty cycle, D is equivalent to V naught over Vs. Okay, so here we can, from this relation over here, we can conclude that the ratio between V naught and also V output voltage and also the input voltage, we can control that by using the by controlling the duty cycle, meaning that the timing for on and off of the switch. Okay, so here the conclusion is that we can conclude. Again, we can control the ratio between output voltage and input voltage by controlling the duty cycle.